Hello, first-time coders. Today we would be discussing functions. Sometimes when you are writing code, the number of lines get out of hand. You will have so many lines that you need to find a way of managing your code. One very good technique is to group your code into functions. So each group performs a specific task, and then you can call one group or the other depending on what you really want to achieve. So we can call this function 1, we can call this function 2, and function 3. So how do functions work? Well, the functions work just like your regular code, but the difference is that um, while you are running the code, let's assume this is the main code here, you can call a function, give it some problem, wait for the function to solve the problem. After the problem is solved by the function, then your code will continue running from the point where it left. This has several advantages. Some of the advantages are it allows you to use the same code in many places in your writing. This will reduce the amount of code you need in your program. Also, it enables you to break complex problems into smaller pieces. For example, if you have a uh, a, a program that calculates the that finds the solution of uh, quadratic equation, so we can have a function that will do this, that will calculate this. Let's say this function does the calculation, and then this function takes the result and check it whether it's a complex number or not. And then finally, another function will do the calculation for uh, x1 and x2. Okay, so that's the advantage. It allows you to break complex problems into smaller pieces, divide and conquer. It also improves your code readability. So if I'm going through the code, I would be able to understand, okay, this part does that and this part does this, without much difficulty. So it also helps in information hiding. Sometimes when there is too much details, the programmer gets confused. So this allows you to hide uh, unnecessary information that has nothing to do with the particular problem you are solving, so that you can focus on the problems you are trying to solve. Um, Another thing is it gives you modularity. So what we mean by modularity is that your program can be broken into smaller pieces, and then you can give these different pieces to different teams, and all these teams can work at the same time, speeding up the production time. And then later all these different pieces can be brought back together, just as we do with cars and other engines. So let's try some code. Let's say we have a program that collects input from the user and calculate the average. So we can just have um, this, and then we can say if the number is not negative, let's read that number into our data. So we add it to the data. Then after that, we ask the user to input another data. Sorry, here we are supposed to just ask the user. Let's say we are trying to get the average of the weight of chickens in a farm. So we check if it's less than 0, then if it's not less than 0, so if it is greater than 0, and then we add that, and then we ask the user again. So we can ask, we can say, so this will get us the numbers, and then after that we can just do the summation. Sum equal to total equal to sum of the data, and then we can calculate the average by saying, okay, the total, but first we have to make sure that the size is not 0. If len of data is greater than 0, then we can say total equal to, sorry, average equal to total divided by the size len of the data, so the data size, and then we can print the average weight is, and then we can just put the average here. So if it is 0 or less, then we say no input is added. So if you run this, you can see if we put the numbers. So let's say if I put a negative number, no input is added. But if I actually give it numbers, like and then I put a negative number that will help me get out of the loop, then we can calculate the average. So now let's say we want to break this into functions. So we can just copy this. Now we can break this into functions. We can start by saying we have data. Let's call the function. To start a function, you use the keyword define. So let's call this function collector, which will collect input from the user. So because this function has no need for any input, we will leave it. We will leave this bracket empty. So inside the bracket, that's where you put all the things the function needs to work. Okay, so we create a function, and then we shift everything inside that function. So after collecting all the input, we can just say return So return is like a portal that allow us to leave the function, and it needs us to give it the information that we want to send back to the to the program that called the function. So now this is our program. Now we can, when you run this, you will get an error. Oh, sorry, we have to refresh the kernel. So if you run this, you'll get an error because the computer doesn't know what data is. Because in the eyes of the computer, this is barricaded. It's inside a wall. So it cannot see what is inside it. Whenever you use the keyword define, what you are doing is you are indirectly creating a wall blocking that set of code. So there is no way to get in or get out of this block. The only way we can enter this block is if we call this function in the other part of the code. So what happens is that when your computer comes, it will ignore this part. It will just take note that, oh, this function exists here, but it cannot enter. So it will start running the code from here until the end. So we have to find a place to call that function somewhere in the code here. So we can just say, okay, call the function's name collector. It doesn't need any input from us, but it is going to give us something as when it's returning back to the function. So let's call that uh, result is equal to. So now we can change all this data into result. So what's happening here is that this, if you remember, we said this part of the code is blocked. We cannot see what is inside. So what happens is that when you say when the code comes, it will start from line 11. Line 11 says collector. When the computer sees these brackets, it knows that collector is a function. So what does it do? It looks for collector. It will remember, oh, I have seen this before. That's why it's very important all your functions should come before the main part of the code down below. So it will remember that, it will remember seeing this. It will just go and enter into this function and start the function. So in the beginning, we create this data, we ask for the inputs, and then when we finish, we will return this result or this data and put it inside the results. So let's try it here. So now if you run this, what do we have? So you can see because of line 11, it is able to enter inside the function. So we can put some values. So you can see after the values enter result, and that's why we are able to continue with line 12. The results are then further processed in the main part of the function. Okay. So one thing you would notice is that the variable data is gone. You can see I cannot get anything when I put data. It says data undefined. But if I say results, I can see values in result. Well, that's because um, whatever variable you create inside a function only exists inside that function. Once you get out of the function, that variable ceases to exist. So we one thing we can also do is we can uh, make this a little bit nicer by hiding this part of the code inside a function too. So this way we can say this is our main part of the code, and because it's not collecting anything, we can just put it this way. So it's not returning anything because it solves the problem itself. We can just say return, and that's all. So now if you run this, let's restart the kernel, assuming there is nothing in the code. Now if you run this, nothing is going to happen. The two defines that we have, this one, the two defines that we have, this one and this one, will block the main function from actually entering into the will block the compiler from entering any of these functions. So when it comes, it cannot enter this, it gives up, it tries this, it cannot enter, it gives up. So it comes after line 20, but there is nothing, it comes to line 20, but there is nothing to execute at line 20. So how do we force the Python to start with our main? We have to call the main function ourselves, because Python doesn't know that it should run the main. So we can just put main at the end. Now when you run the code, you can see it is running fine. Okay, so in summary, what we should focus on is that whenever you create a function, the questions you should ask yourself is, what is the name of the function, which is this one? What inputs the function need? So far we have seen functions that need no input. And then what is the function returning? In this case, the function is not returning anything. In this case, the function is returning with with the contents of data. However, remember that all functions that you create inside, all variables that you create inside a function will die immediately you leave the function. Thank you for watching, and see you next time.